Hello dear learners, this is Siksha Vinay. I am Arun Ranjan and I am going to discuss more about basic principles of chemistry. I have already discussed in the previous lecture that about the laws of combination. In this lecture, I will deal another laws of combination of chemical combination. I will also discuss in this lecture that Dalton atomic theory, and I will deal that what are the concept of relative atomic mass, which is also called AMU, or unified atomic mass, which is also called U. So stay with me. I will discuss all about this in this lecture. Hello dear learners. In this lecture, I am going to deal another law of chemical combination. Here is the law of gaseous volume or law of combining volume, which is given by Gay-Lussac. This law states that if temperature and pressure is taking constant, then the gases always combine in a simple fixed ratio by their volume. Means it is the same law as we have already learned as the law of definite proportion, which is also called law of definite proportion by mass. But this law is actually the law of definite proportion by volume. Means here you have to keep in mind that you have to take temperature and pressure. This is the necessary condition for this. For this law, you have to take temperature constant and pressure constant. But in the first law, the law of definite proportion by mass, it is not necessary that you can have normal temperature at normal temperature or at any temperature pressure, but the mass is always conserved. But in this case, gases combine in a simple ratio only when their temperature and pressure is keeping constant. So here I am giving you an example that if hydrogen gas and chlorine gas when react to each other in a favorable condition, then it gives it produces HCl hydrochloric acid. In now the main point is here considered is that every species must be in gaseous form, because this is law of gaseous volume or law of combining volume. That means you have to consider all these constituent and product or reactant and product in gaseous form. It is a necessary condition. If I react sodium and chlorine, then sodium must be in the gaseous form, not in the solid form or liquid form. So this law is valid when we take all these species in gaseous form. So you have to here you have to see the ratio is 1:1 by, because if you can balance here one volume becomes two volume. This ratio between the reactant species are 1:1. This is simple all number ratio. Now I give you another example so that you can understand the practical meaning of it. So if you take hydrogen and oxygen in your lab and take hydrogen 100 ml and oxygen 50 ml, then you will find that the water is produced with volume 100 ml. It is sure that you must have found in the laboratory that you have gotten 100 ml water. It is the law of nature. So in this way, if you take the ratio of hydrogen and oxygen without knowing the balancing of equation, just you estimate the volume of these species by the experimental methods in your laboratory, then you will find that this ratio becomes a whole number ratio. That is here 100 ml is to 50 ml becomes 2:1. simple. But this law is given by Gay-Lussac, but it is not fully explained by Gay-Lussac. It is fully explained by Avogadro in 1811. And Avogadro also gave a new kind of law, which is called Avogadro hypothesis or Avogadro law. So here the another law of combination, chemical combination, which is given by Avogadro. It is very important that if you take temperature and pressure constant, and it is the necessary condition that temperature must be 273 Kelvin and pressure must be 1 atm, means you have to take these species at STP. STP means standard STP. STP means standard temperature and pressure. Standard temperature and pressure is 273 Kelvin, and standard pressure is 1 atm or 760 mm of Hg or 760 torr. Have you got my point? So this what this law states is that each volume of all the gases have equal number. Here you must here consider that it is not given for atoms. We don't have to count atoms, but we have to count molecules. At STP, if volume is fixed, then all gases have equal number of molecules. Have you got my? So Avogadro made distinction between atoms and molecules. Here you can see here he said that molecules is different than atoms. We cannot mention atoms for molecules for atoms. They are different. So he mentioned in his law that each volume of gases, the particular volume of gases count equal number of molecules. Doesn't mean equal number of atoms. For example, if at the particular volume hydrogen gas molecules count n molecules, but an NH3 gas count n molecules according to this law. But here you can see atoms in the hydrogen gas is 2n atoms, but the atoms in the ammonia gas is 4n atoms. So it is. Have you got my? So this is the necessary point. You have to understand it that the Avogadro said that the number of molecule is same for each volume of all the gas. Whether you take hydrogen gas, whether you take oxygen gas, sodium gas, or any kind of vapor you take, but the volume, the number of very important law. He also considered the same kind of atoms can combine with each other. Even Dalton and others doesn't believe on that same kind of atoms can produce can combine to produce a new kind of molecule. They believe that same kind of thing cannot combine. But Avogadro have shown that they can combine, and we already know that O2, H2, N2, these kind of molecules can be must be formed from the atoms, like oxygen is O2 molecule is formed by oxygen atoms, and N2 molecule is formed by nitrogen atoms, and so on. So Avogadro was the very important scientist in the history of chemistry. So when the General Conference on Weight and Measure are held in 1971, then they adopted a new kind of unit which is called mole as SI unit of amount of substance. Then they proposed that how much volume you have to count for a standard. So they proposed that you have to take 22.4 liter of any gas at STP, and then the number of molecules are our standard number of substance. Have you got me? So in the General Conference on Weight and Measure, all the scientists have discussed about it and proposed that you have to take 22.4 liter at STP of any gas or any matter in gaseous form, then we have to count the molecules, the number of molecules, and we got it, and then it call it 1 mole. Have you got my? What is 1 mole? You have understood or not? They propose that uh, because substance are made up of very tiny particles, so we cannot count easily. Have you got my point? So in chemistry, dealing with numbers of atoms are very lengthy or very very hard. So we must have to take an standard by which we count some. For example, we have to take a unit that, let's say, there is one unit possesses 5 molecules, then 18 unit possesses 90 molecules. In this way we can count the numbers for our study to be easier. Have you got? So they proposed that in 1971 that we have to take a SI unit of amount of substance, which is we call mole. Mole means means heap or bundle or pile of something, which is Greek word. So they say, that every substance is made of many atoms or molecules. So we can we can say in common language that they are heap of or bundles of molecules or atoms. So they call that that this a unit of amount of substance we call mole, 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 and we abbreviate it as MOL, mole. And by the Avogadro law, they already had proposed which state that each volume of all the gases contain equal molecules at STP. So they propose that you have to take 22.4 liter for all the cases as a standard. So we call that at 22.4 liter all the gases have equal number, and they calculate that at 22.4 liter we call that the number of molecules is a unit we call mole. So number of 1 mole of any gas is equivalent to 22.4 liter of substance in gases. Have you got? This is also they call molar volume. About these things we will study in detail, but here I have discussed all the laws of combining chemical of law of chemical combination. So I hope that you have understood all the laws and you have to care about their condition and what they what they have practical meaning about it. So now I am discussing about Dalton's atomic theory. Dalton's atomic theory, we are already, I have told you that all the metals, all the substance consist of tiny particles, which we call atom. And the Dalton's, when Dalton's, every morning, Dalton collect the data of weather. So when a rainy season, he observed that that the rains are fall on the ground, and an idea was struck in mind that every particle is of some tiny indivisible particles. So they proposed a proposed a theory on the basis of this idea. So they all these things, all the idea they propose, which we published in a paper called A New System of Chemical Philosophy. In this philosophy, they propose that matter is made up of individual particles, which we have already known about it. Or next is, it is easier for you, and next is all the atoms of a given element is identical. So so if you take sodium has sodium atoms. All the sodium atoms have same property, same mass, same shape and size. So every property of all the atoms of the same element is identical. This and atoms of different elements are different. So and if you take sodium atom, if you take aluminum atom, the behavior of properties of aluminum atom is different than the properties of sodium atoms. This hypothesis say about. But here I am writing here this is false because sometimes the property of some element, some atoms may be same with some respect. For example, if I take isotons or isoelectronics or isotopes, we can see in the isotopes. I give you example that calcium and argon has same mass number, which is called isobars, and isotopes like same atomic number but different mass number. For example, carbon 612 and carbon 613, carbon 614, which have same which have same property with respect to number of electrons and protons. But this hypothesis said that all the atoms of different elements are different in all the. But here you can see that in the respect of number of electrons and the number of protons, isotopes. Have you got my point? So this is false about it. And the next hypothesis is chemical reaction involves rearrangement of atoms, cannot be destroyed or cannot be created. This is very important thing that that in a chemical reaction you cannot create a new thing, new atom or you cannot destroy an atom because when a hydrogen and oxygen combine, it gives water. Water seems to be different than hydrogen and oxygen, so a mind can think that that water is somewhat new kind of substance than hydrogen and oxygen, and they become happy that I have created a new kind of substance. But in deep, if you experiment on it and you think deeply, that nothing in this universe you can create you can create new matter. Just rearrange it in a new way, and that's why the property of these things become different than earlier. So hydrogen and oxygen arrange in a different manner, so that the property of these substances become different. So water becomes liquid and hydrogen and oxygen become remain in gaseous form. So so we cannot create matter and we can create destroy it, but we can rearrange it in a new way that you can have new kind of substance. So this is the third hypothesis of Dalton atomic theory. Now but here is the new point I have got, that in the modern times we know that matter can be destroyed or can be created, maybe also, because Einstein relativity theory showed that even a small amount of substance can produce large amount of energy. So by energy we can create matter, and by matter we can destroy it, and we create energy. In this way we can say that mass can be destroyed and can be converted into energy, and energy can be destroyed and converted to a mass. So in this way it is wrong, but overall it is right. Now now the next thing is fourth and last hypothesis of Dalton is compounds are formed uh, compounds are formed when atoms of different elements combine in a fixed ratio. We have already studied about it, that when compounds are formed, the atoms of different elements combine in a simple Hall ratio. But sometimes it may be not a simple ratio. For example, if I say Fe as 0.980, this is also a compound which is called non-stoichiometric compound, which have no simple ratio, which is ratio of ferrous and oxygen. Here is 0.98 is to 1, which is not a simple ratio. So this is also sometimes false, but overall it is. So Dalton take all the discoveries before that or during his lifetime, and proposed a new system of philosophy in which he proposed four hypotheses, four main hypotheses I have here written here, and I have explained to you. So now I have discussed in this lecture about the law of combination and Dalton theory. We will deal more about basic principle of chemistry in the next lecture. Thank you for watching. Now I am discussing about relative atomic mass, RAM. It is first proposed by John Dalton, which is the great contribution of him. What he proposed that mass of one atom should be expressed with respect to a fixed standard. As in science, we know that we have to take a standard by which we can measure the the data by using the reference. So in physics and in mathematics also we have to take some standard reference. So he proposed that hydrogen is used as a standard for the mass, and we have to take the mass of hydrogen atom is 1 unit, means all the mass of all the atoms is expressed by this the mass of hydrogen atom. So if we take hydrogen atom, mass of hydrogen atom is 1, then we can calculate the mass of oxygen atom, mass of helium and lithium atom using the standard parameter of mass of hydrogen. Means this is not the actual mass of hydrogen. We have to take it as at standard. So we assign a value 1 for the mass of hydrogen atom. Have you got my point? So if let's say that helium is 2 times massive than hydrogen atom, so we can say that the mass of helium atom is 2 unit with respect to hydrogen atom. Have you got my point? So you can calculate it by unitary method also. So we can say that mass of any atom mass of any atom is RAM is into mass of one hydrogen atom, means actual mass of one hydrogen atom into RAM, relative atomic mass. Means we assign a relative mass with respect to hydrogen, that if we take let's say lithium has relative atomic mass is 3, that means its actual mass is 3 into actual mass of one hydrogen atom. Have you got my point? So in this way we have to express all the masses of all the atoms using RAM concept. Later on, oxygen is used as fixed standard. Hydrogen is replaced by oxygen. So we can say in the same way that mass of any atom must be RAM into 1 by 16th of mass of one oxygen atom. Why? Because oxygen atom has mass 16 gram in 1 mole. That's why we have to take one oxygen atom only, the mass of one oxygen atom only. So we have to replace it by 1 by 16th into mass of one atom as our standard. So the mass of an atom must be RAM into 1 by 16 mass of one oxygen atom. For example, if let's say an atom X has RAM 5 unit, it means its mass is 5 into 1 by 16 into actual mass of one oxygen atom, if we take oxygen as our reference standard. Have you got my point? So but in 1961, international scientist community have decided that you have to take C12 isotope, carbon C12 isotope. Carbon has 3 isotopes mainly, that is C12, C13 and C14, and C12 is 98% is found in nature, and we can see everywhere in our living world that carbon is present. So the scientists take it as a standard for the measurement of mass of all the atoms. So C12 means C612 means atomic number of carbon is 6 and the mass number is 12. This atom is taken as our reference for the measurement of mass of any atom. So now after 1961 we only we only measure the mass of all the atoms in terms of carbon 12 isotopes, and we will study about it in detail in this chapter. So we in the similar manner we can say that mass of any atom with respect to carbon 12 isotope is RAM into 1 by 12 into mass of one carbon atom. Have you got my point? So if let's say the element A has mass RAM 10 unit, then the actual mass of this element must be 10 into 1 by 12 into actual mass of one carbon 12 isotopes. Have you carbon isotope atom? So have you got my point? That is the meaning of RAM, or relative atomic mass. Means by this taking reference point, and we must have to know in this way that actual mass of one carbon atom is what. So various scientists and experimentalists have discovered that mass of one carbon atom, and they discover some devices called mass spectroscopy, by which we can calculate the actual mass of one carbon 12 atom. So after this they define the unit of for the amount of substance with respect to carbon 12 isotope, which is 1 by 12th of mass of one carbon 12 atom. Have you got my point? So we call it now that it is 1 AMU, means atomic mass unit. We call this value, this unit is as 1 atomic mass unit. 1 by 12th of mass of one carbon atom is called 1 AMU. As I have already told you that it is same as 1 into mass of one hydrogen atom. It is same as 1 by 16 into mass of one oxygen atom. Have you got my point? So this this term, or this definition is given for atomic mass unit AMU. Have you got my point? AMU is also called Da for Dalton, because it is first proposed by John Dalton. So by the mass spectroscopic, I have told you that this device by which we accurately measure the mass of an atom, which is found to be 1.992648 into 10 to the power minus 23 gram, mass of one carbon 12 isotope atom. So 1 AMU actually the mass of 1 by 12 into one carbon atom, that means 1 by 12 into this, and we if we calculate it, we found that 1 AMU equal to 1.66056 into 10 to power minus 24. In our calculation, we have to take 1.66 into 10 to power minus 24 gram, and you have to remember it. So 1 AMU is nothing but the mass, which is equivalent to 1.66 in 10 to power minus 24 gram. So using this unit AMU, we have to now calculate the mass of other atoms. So if any atom has 5 AMU mass, it means its actual mass is 5 into 1.66 into 10 to the power minus 24 gram. Have you got my point? Now you have understood the AMU, and this is we have to express RAM and AMU in the same way. We have already known that the mass of an atom of an element is RAM into 1 by 12 into mass of one C12 atom by the definition of RAM. So we have now defined a new term, that AMU is nothing but 1 by 12 of mass of one carbon 12 isotope atom. That means atomic mass or mass of an atom is nothing but RAM into 1 AMU. Have you got my point? So So if you consider consider mass of one molecule, not atom, then we say that it is molecular mass, not atomic mass. That's why molecular mass, we can extend this concept in molecule also. So we can say that molecular mass is RAM into 1 AMU. Have you got my point? Later on, this AMU is also abbreviated as also said as unified mass unit, which is denoted as U. So in our calculation, in this chapter, we can use AMU, or generally U is used for the simplicity. So for example, I am giving you some example for you, that RAM for hydrogen. How can you calculate the RAM for hydrogen? So we know that mass of one atom of hydrogen is nothing but, means atomic mass of one hydrogen atom is nothing but RAM into AMU. Have you got my point? I have already told you. That means mass of one atom is found to be 1.6736 in 10 power minus 24 gram by the mass spectroscopy, and I have calculated that 1 AMU is nothing but 1.66056 into 10 to power minus 24 gram. So if you divide it, we can find the RAM of hydrogen, that is 1.007. Have you got my point? This means atomic mass of hydrogen must be RAM into 1 AMU. I have already told you RAM into 1 AMU, that is molecular mass, or atomic mass is RAM into 1 AMU. That means it gives RAM of hydrogen is 1.0078 and into 1 AMU this. So it becomes 1.0078 AMU. It means this can be also written as 1.0078 U. That means atomic mass of hydrogen is 1.0078 U, or you can say by rounding off to 2 decimal places or 1 decimal place, it becomes 1 U. Have you got my point? So now we can take another example as oxygen atom, oxygen isotope of 0 or 16. We can calculate it at its atomic mass as 15.995 U. In this way, we can find the mass of any atom in terms of AMU. Have you got my point? So if you have any if I hope that you have understood all the concept. You have to think about it and practice all the concept and laws of combination and AMU concept. I will deal